Hi, everyone. So we still have like 14 minutes before the session starts. So questions, please, if there are any. So any questions? From anything that we have discussed already or anything else from the codes? Or on-prem or Azure security in general? So what we did in the previous session was the first task in hands-on 5. We elevated privileges to local administrator on our foothold machine. We'll start today's session with the second task. That is to identify a machine in the domain where student user X has local admin privileges. There is a question about a problem with a mimikatz command. This doesn't look like an elevated shell. If it is, then you may like to check the version. The version seems fine as well. Now are you sure that this is a high integrity process? That is, it is an elevated shell. Because this secure LSA, acquire LSA, that usually shows up when you are not running it from an elevated shell. A question that is about a later hands-on is, when we are abusing forest trusts, is there a way to enumerate what resources are explicitly shared with our current? So usually when we talk about across forest abuse, so there are two ways you can do that. One is, if you're talking about cross forest abuse, you can always assume that in your current forest, you would go through documentations, emails, access history, etc. So that would help you in finding out that, okay, these are the resources that users from the current forest are able to access in the other one. So that is, you derive that information from your access, your existing access. Now, talking about pure enumeration terms, in pure enumeration terms, this is something that we can use. Enumerate. You can request TGS or service ticket for different service principal names in the target forest, and then go ahead and try to access them. That is one way, right? For example, you request a service ticket for CIFS on the DC or on any other computer object that you see in the target tenant, sorry, the target forest, and then go ahead and try and see if you can access that. Another way is to use plain old port scanning. Port scan the IP ranges of the target forest and see if you can find a machine, and then probably you can try to request service tickets for well-known services. What are well-known services? Like HTTP, that is WinRM, RPCSS plus host, that is WMI, host, that is scheduled tasks, and so on. A CIFS, that is file system. So you try and access them one by one. That could be one of the ways. Not very easy to do, but that is one of the ways that I would recommend. You're welcome. I was sore throat today, so please excuse me for that. Another question is, should we be able to port scan target devices from our Kali on the VPN? I don't think so. I don't think so, but I can double check that for you. Any other question? Or the setup would be pretty similar in the exam as well. If you want to use a Kali machine or Kali VM, I need to ask my team to be absolutely sure about that whether you can access, or if you want, you can, because I've started the session now. If you want, you can drop them an email right away and ask this. I believe that is not possible, but maybe as well. I mean, to be honest, I'm not absolutely sure about that. So that's the answer to your question, Dad. I mean, there is a user whose handle is Dad. All right. A question about overpass the hash is, do we need to load mimidriv.sys while using that? No, that is only if you would like to avoid, if the LSS process on your target machine is running as PPL, only then you would need the mimidriv.sys. Otherwise, you won't. You won't need that. Is there a way to spawn a PowerShell from a domain joined machine, even though PowerShell is not installed? So PowerShell.exe and the DLL, that is system management automation, they come present by default on a Windows machine. If the PowerShell.exe, that is the blue console that we have here, if that is not enabled or it is blocked, then yes, you can use a lot of Microsoft signed binaries to load the DLL. Check out the LOLBus project for that. Yes, that is correct. You may like to wait till I think in today's session, we'll cover that. When you use overpass the hash, the new process starts with logon type 9. Now, logon type 9 uses the new credential only when you access a network resource. So for whoami, it would still be in the context of your current user, that is student user. Any other question? Now we are still waiting for, there are a couple of minutes before the session starts. If you are on the Zoom call, Mr. No, it has not. It's just the pre-session question and answer right now. Oh, yes, you are. Any other question? We still have a couple of minutes before the session starts. Now let me wear just a few seconds early. So let me start today's session because there are no more questions and I don't want to sit idly. Session link is same as the previous one. All right, so let me start today's session now, actually. Hi, everyone. Welcome to Active Directory Attacks, the Advanced Edition Bootcamp. This is the March run of the bootcamp, and this is session 2. In the previous session, we completed the first task of hands-on 5. That is to escalate privileges on our foothold or beachhead machine, the student VM. That is what we did in the previous one. Now, the second task that we are going to do right now is to identify a machine in the domain where student user X has local administrative access due to some group memberships. Okay, fair enough. So the question tells us that we would need to enumerate group memberships for the student user. Now, if we enumerate group memberships using the AD module, get AD principal group membership is the commandlet, and we can check it for student user 1. So what we get here is student user 1 is a member of a couple of groups. However, what AD module fails to show is the membership of, what it fails to show is recursive membership. That is, what if the student users group is also a member of another group, and if that group is also a member of another group, and so on. Please note that Power View excels here in this sense. If I load Power View here in another session, and if I specify student user 1 here, let me see the command. I couldn't simply recall that right away. Sorry about that. So that's Oh, it's get domain group dash username. So if we take a look at the output of Power View, we would see that the student user X or the student user is a member of multiple groups. So that recursion, that the ability to list the membership recursively is missing in get AD principal group membership. So if we are adamant that we will try to solve this problem right here using the AD module, then we can program some recursion here. Now, recursion in any programming language, the best way or the easiest way to apply recursion is to create a function and call the function from its own body. And that is what we are going to do using this simple code. What are we doing here? We are defining a PowerShell function called get AD principal group membership recursive that accepts a parameter SAM account. Now, this command lists all the groups that the SAM account name or the user is a member of, and it keeps calling itself as long as the group count remains greater than 0. So it will keep calling that, okay, if student user 1 is a member of domain users and student users, then okay, is domain users a member of any group? Yes or no? No. Is student users a member of a group? Yes, it is a member of a group called, let's say, managers. Then, okay, is managers member of a group? Yes or no? That is what it keeps doing. And we'll get to know that, okay, student user X, or in this case, student user 1 is a member of domain users, student users, users, maintenance users, and managers. All right. Now we need to find out that if any of these groups has any interesting permissions, that may result in the second task. That may result in what we want to do in the second task, that is administrative access to any other machine. So now what we can do is we can start enumerating ACLs for these groups. We have already done it for student users in a previous hands-on. We can check it for maintenance users and managers. Now, one way to do that is using Power View. We can run this command. Please note that because of the number of ACLs, this will take time, will eat up a lot of CPU. So you can try this later on. I'm not going to run it right away, just to save time. It will take at least a couple of minutes to finish. But this shows us exactly almost the same thing that we'll get from this command. So here we are looking for all the interesting ACLs and filtering it out for where the identity reference name is managers. How do we know that we need to do it for managers first? I mean, it's just a guess, all right? Or for the sake of the lab, we can say that we assume. Now, the result that we would get from this can be seen from here as well. Here, although we are assuming that it is the machine admins group where the managers group would have some interesting permissions. Let's first take a look at it. Once again, please note that we are simply making an assumption there to save time. That is, we all somehow already know that it would be on the machine admins group. So what we find out from here is on the machine admins group, the US managers group has read property, write property, create child, delete child, read property, anything else, and generic all. On the machine admins group that is part of this OU MGMT, the US managers has generic all. Is there an easier way okay, I just saw this message. I'm sorry. Mr. Look, are you able to access? Are you in the Zoom call now? Okay, great. Now, is there a way to easily enumerate this? Yes. Now, scenarios like this is where Bloodhound excels every type of every visualization that you may have by looking at lists. This is where looking at graph helps you a lot. So if we use our previously gathered information in Bloodhound, what we are looking for is any machine where student user X has local administrative access. Now, because I'm student user 1, let's take a look at it. Now, if I look for group memberships, there is just one membership for first degree local admin. Sorry, not that. Group membership. Unrolled group membership is this user, student user 1, is a member of student users, who is a member of maintenance users, who is a member of managers. Now, here, to be able to move any further, we would have to actually go through each and every group the student user is a member of. But in case of Bloodhound, we can always check this: outbound control rights, transitive object control. And what we would see here is student user 1, who is a member of student users, is a member of maintenance users, who is that group is a member of managers. And managers can add member to machine admins. And this is where the famous quote from, I could not recall the full name of John, of course, from Microsoft, that attackers think in graphs and defenders think in lists. As long as this is true, attackers will win. So as you could see, doesn't hold true always, but that is a very good quote, and that is exactly applicable here, as you could see. It is much easier to visualize this now. That, okay, this simply means that if student user 1 or any of the members of the student users group is compromised, any of the members of this group is compromised, that would mean access to the machine admins group. Now, from our previous enumeration, and once again, Bloodhound may not be the ideal candidate always. Please always keep that in mind. Now, where have we seen machine admins? Would anyone like to answer? We have previously seen the machine admins group somewhere. Anyone? Recall the enumeration that we did for restricted groups. Exactly. Now, machine admins is a member of local administrator group or local administrators group on any machine in the MGMT OU. Recall that there was just one machine, US MGMT, in that OU. This means that now, if we add our user, any user to the machine admins group, we would be able to get local admin access to US MGMT, and that is what was asked in the task. Let's stop this. And now we are going to add a user to the machine admins group. Please always keep this in mind. I've also left a description in the group. Always check descriptions as well, if there are any that could be helpful. Now we are going to add a user to the machine admins group. Please note that changing group memberships is something that you should only use when you are absolutely desperate and nothing else is working at all. All right. Adding members to a group is a very high noise activity, and tools like MDI may may be looking exactly for that activity. So please don't do that unless there is no other, absolutely no other way, or you absolutely know what you are doing. But here, let's take that freedom. Let's add our current student user or foothold user to the machine admins group using the add AD group member from the AD module. So if you look at the group information with our current access token, you won't see the machine admins group here. So we may need to log off quickly and log back in so that our new access token contains the membership of machine admins group as well. So if I run whoami/groups here, you would see that now we have membership of the machine admins group, and it would be possible for us to simply go ahead and access that, let's say, over WinRM. Or better, let's simply run CMD there so that we have an interactive session on USMDMT. All right. That was our task 5 or task 2 of hands-on 5. And this is where we are. We could access USMGMT thanks to OU delegation. Now, why I have OU delegation here? Let me show you the reason for that. Sorry. So I'm logging into the DC, share the screen in a moment. So here if you see on the DC, I mean, we of course had this local admin access due to group membership as well, but why or how did the managers group had full control over machine admins? Now, the reason for that was if you look at the ACL of the MGMT group, of the MGMT OU, you will see this, that the managers group has full control over the OU. Now, is it common in enterprise environments? Yes, that is what happens when you delegate control of an OU to another user. That is what delegation is. Delegation is applied using ACLs. And that is why we spent and we will still spend more time on ACLs. That those ACLs are the basis of access in Active Directory. All right, so that when you run the delegation of control wizard, the rights that you give to a user where you're delegating the administration, those are enforced or those are granted using the ACLs. right? So that is why it was possible for us to access US MGMT. Now, what we used here was WinRM using the WinRS client. So before we touch that, let's talk about partial remoting. Those of you who have never used or seen partial remoting, think of it as PSExec on steroids, but much more silent and super fast. Unlike PSExec, partial remoting does not install or service on the target machine or drop an executable onto the disk. And that is the reason why it is a lot more silent and super fast. PS remoting uses WinRM, Windows Remote Management. WinRM is Microsoft's implementation of WS management, which is an industry standard for inventory management. Partial remoting is enabled by default on Server 2012 onwards for server operating systems, and a firewall exception is added on Windows Firewall for it already. WinRM by default listens on port 5985 HTTP and 5986 HTTPS if SSL is used. Partial remoting is the recommended way to manage Windows core servers. On desktop Windows OS like Windows 10, 11, etc., you need to enable remoting, and administrative privileges would be required to do that. Please note that when you partial remote to a machine, you get a high integrity process. That is, UAC, etc., are usually not a problem. You get an elevated shell on the remote machine. Right? There are two types of partial remoting: one-to-one and one-to-many. This is what one-to-one looks like. You can use enter PS session or new PS session to interact with a machine where you have administrative privileges. By default, you need administrative privileges to access a machine using partial remoting or WinRM. Right? Please always note that when you remote to a machine, it is not PowerShell.exe that spawns up on the remote machines. It is WSM proc host. All right. Keep an eye or keep in mind this all the time. This is what Kerberos double hop is. I will discuss this when we talk about delegation, but please always keep in mind, if you face anything like this, this is working as intended. This is not an error. If you face this in the lab or the exam, it's not an error in the lab. If you face it in a real world assessment or your own organization's environment, this is not a problem. This is a security control, right? Even inability to do this, that is a security control. That is not a problem. But we'll come to that later on. We can also store sessions in variables. Now, this variable US MGMT right now holds the session that we have on the US MGMT machine. We can always interact with it. Oh, it's US MGMT, my bad. All right. Now, this is sweet, but not very useful. I mean, in all cases. Why? Let's say you have to run a command or a script on 10,000 machines or 50,000 machines in a single go. Now, this obviously does not scale. So what scales is one-to-many remoting, also known as fan-out remoting, that is non-interactive, and it runs commands in parallel on all the machines. The commandlet that is used for one-to-many partial remoting is invoke command. Invoke command is absolutely fantastic. You can run commands and partial scripts on multiple remote machines, even in disconnected sessions, as background jobs, etc. This is very useful for any credential replay attacks. However, please keep in mind partial logging, etc. So you can use invoke command -script block. You can specify a script block here, or a single command, or a whole script here. And then the computer name parameter, if you pass a list of target machines, let's say 50K machines or more, this command will be executed on all those machines in parallel, not one by one, but in parallel. Not only that, invoke command has the capability to run local PowerShell scripts in memory on remote machines. So if you run the below one, invoke command -file path of the script, then when you run this, what happens is this script is read from the local machine, converted to a base 64 encoded script, and then executed in memory of all of these servers. That is what makes partial remoting very attractive. You can also run locally loaded functions to remote machines. The idea remains the same. The code is read from the function store, converted to a base 64 encoded block, and then executed on the remote machines. You can also pass positional arguments. That is, if you want to pass arguments to this function, you can do that as well. However, and you can also use the session parameter even with invoke command. So for example, if you want to run let's say host name, who am I, etc. in a session using invoke command, you do that. All right. However, PowerShell remoting supports system-wide transcripts and deep script block logging. That is, the reasons why we are not using, why we are calling PowerShell from InvisiShell, that applies also on PowerShell remoting. So is there a way out? We can actually use WinRS in place of PS remoting to evade the logging. You can use WinRS or WinRN.VBS or even the WSMan.com object for additional OPSEC. The access remains the same. The underlying protocol where WinRM remains the same, but the logging goes away. The enhanced logging goes away. So we still can have the benefits of port 5985 and 5986 allowed between hosts, and we evade the PS remoting logging. Right? You saw how we can use it. And we'll keep coming back to this actually. All right. Now there is a question, which is more silent, using partial remoting or RDP when we have the credentials? I would say partial remoting. I mean, I may be biased because I've used partial a lot, but in my opinion, RDP is absolutely very, very noisy. And a lot more than partial, I would say. Having said that, nothing beats an RDP session, not even partial remoting or anything like that. Why? When you RDP to a machine, you get the user's desktop context. Now, in some rare cases, you may, for example, let's say if you want to run a keylogger. Now, many keyloggers, at least the ones that rely on the old school get async key state to get key press events, those need the user's desktop context. That is, it must be run from an interactive session onto the user's machine. So other than those cases, usually partial remoting or anything that does not take away the session from a user accidentally is always better. Having said that, a lot of APTs also use RDP. I mean, it depends entirely on how your target organization's security structured, what is their security posture, how well they respond to things like this. right? Now, now we can, once we have local admin privileges on our foothold and one more machine, let's now start hunting or actively looking for ability to access other machines in the network. So now we can go in the admin recon phase. That is, can we now access other machines in the domain? So we'll abuse Kerberos for that. Kerberos is the basis of authentication in Active Directory, where clients, that is programs on behalf of a user, need to obtain tickets from Key Distribution Center, KDC, which is a service running on the DC. Now, these tickets represent the client's credentials and therefore are pretty important. Now, because Kerberos is the de facto authentication mechanism in Active Directory, it is very interesting and ripe to abuse. So this is what Kerberos functionality looks like. Let's say this client on behalf of a user wants to access a service running on this application server. Now, this is how the authentication or the access flow happens. The user's password is converted to NTLM hash, or let me say it this way: a timestamp is signed and encrypted using user's NTLM hash or AES key and sent to the DC. Now, because the DC has access to all the secrets in the domain, the DC decrypts that timestamp using the user's key, validates it, and responds with a TGT, a ticket granting ticket. Now, a TGT is encrypted and signed using secrets of a special account called KRB-TGT or Kirby-TGT. Now, at the end of step 2, the client cannot decrypt the TGT, so it sends it back or presents it to the KDC as a proof of possession and requests a service ticket or a TGS for the service principal name or the service running on this application server. At the end of step 3, the only validation that the KDC does is if it can decrypt the TGT using KRB TGT user's secrets. If it can decrypt that, it responds with a TGS or a service ticket that is encrypted using target services, NTLM hash or AES keys. End of step 4, can the client decrypt the service ticket or TGS? No, it cannot. So it presents the ticket to the service, to the target service that it wants to access. The target service can decrypt it because it has access to its own secrets. And then it is the target service that decides on users' privileges. The KDC has no role in authorization unless the PAC validation is enabled, which is disabled by default. There is also an optional step number 6 for mutual authentication to stop clients from sending TGS to rogue services. That is how Kerberos works. All right. Now, each step here, almost each step is abusable. The first one that we are going to take a look at is Kerberosing. I'll come back to the slide in a moment. Now, in case of Kerberosing, is this clear? Because we are going to keep coming back to this. Is this clear how Kerberos works, at least at the high level? Okay, great. So now let's talk about Kerberosing. Once again, please note that the only validation at the end of step 3 that the DC does is if it can decrypt the TGT using secrets of the Kirby TGT account. There is no check on if you are authorized to request a service ticket for a particular service. What does that mean? That means that you can, or any authenticated user can go ahead and request a service ticket for any service in the entire domain, or rather in the entire forest. Now, once we get the TGS or the service ticket at the end of step 4, We can skip sending that ticket to the target service, but in place of that, we can save it to the disk and brute force it offline. Offline brute forcing means there would be no log-on count that will increase, and you can throw as much computing power as you have on that brute forcing. Now, this is exactly what the curb roasting attack is. When you get a service ticket or a TGS, you save it to the disk and brute force it offline. All right. So when we say the service ticket is encrypted using the target service's secrets, it's not the entire ticket, but a portion of it, a part of it that is encrypted using the password hash or AES keys of the service account. All right. The only log that you will leave on the target machine when you are running curb roasting in a controlled manner is 4769. Curb roast ticket requested, and there are thousands of 4769s on any DC every day. All right. So unless you run tools like, for example, there is one in PowerView called Invoke Curb Roasting that enumerates all the SPNs and request TGS for all of them. Unless you use automated tools like that, curb roasting is a very silent attack. However, please keep this in mind that it is the users that are not good at creating passwords. What does that mean? That means that trying to target those services that use machine accounts as service accounts would be futile. Why? Because machine account passwords are set by machines and they are super long and very, very hard to brute force. Whereas if you target user accounts, that is normal accounts that are used as service accounts, then chances of success are much, much higher. Now, a question is, how do you find out service accounts? Using this or this. So what is a service account? For the domain controller or the KDC service, any account whose service principal name attribute is not null is a service account. Even if there is no service that is running as that particular account, if the service principal name of an account is not null, then it is treated as a service account and you can request a ticket for it. All right, so if I run this, for example, I don't think we have AD module imported here. So let me start Inquisition. Import the AD module. And then if I run this command, we are filtering all the users on the basis of, we want to see only those that has service principal name not set to null. So please always note that KirbyTGT will always show up, but its password is set by machine. So may not be fruitful to go for it. Now we have two more accounts, an account called service account that has this service principal name or SPN, and an account called app SVC that has this SPN. So a couple of accounts that we can target here. How do we target these? We can use Rubius or built-in .NET classes using PowerShell, or things like Invoke Curb Roast to request a service ticket and then brute force them. All right. A question is there any reference / resources that you can provide or suggest us to see what properties are contained in every ticket? Or you may like to take a look at whenever, for example, even in the lab, install Wireshark on your student VM and look at the traffic whenever you are doing something. So that is a very good way to understand. If you really want to check out what are the different fields and how Kerberos works, so that is one of the very useful ways. All right. Now, if you want to enumerate the same thing, let's say using Rubius. Let's run this. So what do we get here is Rubius tells us that there are two Kerberos table users. Both support RC4 HMAC default, that is RC4 encryption, and the password was set in these years. All right. You can request a TGS or a service ticket using Rubius, let's say for service account, using this. So what are we doing? Using the Kerberos module of Rubius, we want to Kerberos service account, we want the output in a simple form. Now, this is something that you may like to save to a file and pass it on to Hashcat or John the Ripper for brute forcing. So this is the vanilla Kerberos thing with the help of Rubius, I mean, requesting tickets. However, keep one very interesting thing in mind. When we are requesting tickets using Rubius or any other tool that helps you in getting Kerberos table tickets, you would always be, even if you don't know, I mean, the tool in the background would request the ticket to have an E-type of 0x17. That stands for RC4 HMAC. As we saw here. Now, here is a problem. If there is a tool like Microsoft Defender for Identity, MDI, or any other similar tool in the target environment, those tools specifically look for encryption downgrade. What is encryption downgrade? Encryption downgrade is this. Let's say this user service account supports AES. Now, what happens is if you run a command like this, this would be detected as encryption downgrade by tools like MDI. Why? Because the account supports AES, the forest function level is server 2016. Then why the heck someone is requesting a service ticket that is encrypted using RC4? To avoid that stuff, you can use RC4 OPSEC. You see that? When I used RC4 OPSEC, Rubius did not requested a TGS with downgraded encryption. Our question is, why is Rubius performing a downgrade? Because RC4 is a lot easier to brute force compared to AES. Superbly simple compared to AES. That is why a downgrade is forced here. Once again, as you would see here. Now, if I go back here, let's say, and remove these checkboxes, that is AES support is removed for service account, and then I run the same command with RC4 OPSEC, you would see that we do get a service ticket here. All right. So make sure that you always, to be honest, in my opinion, never do enumeration using tools like Rubius. As a user asked that they tried to use Rubius in a real world assessment and it was instantly detected. Yes, it is an OST, it is an open source tool. It is absolutely going to be detected. All right. You cannot expect to use as popular tools as Rubius directly without modification. No, they would be definitely detected. What is the way? We discuss that a bit later on when we talk about offensive.NET Tradecraft. The stuff we did for PowerShell scripts, similar stuff we are going to do for .NET binaries. That is, we make at least small changes that signature-based detection, at least that is defeated. All right. So now we will save this. I mean, once we have this hash in a file, what are we going to do? We can pass it to hashcat or John the Ripper to brute force it. Please always keep in mind that if you have an RC4 hash, even in case of AES, the success of your brute force depends on this. The better your word list is, more customized or tuned it is towards the target environment, more are the chances of your brute force being successful. And that would be it. That is what the curb roasting attack is. Right? And that brings us to hands-on 6. Using the curb roast attack, get the clear text password for an account in our target domain. So we are almost there. We simply need to save these hashes that we have in a file. Let's save it to a file called hashes.txt. So we are targeting service account here. And now we can simply run John the Ripper right from here in the command line. Word list is something that we have made up for the lab. And this is where we stored the hashes. And it would be very fast because it is a very small word list and I've already injected the correct password in this word list. So as you could see, this is what success looks like in this case. All right. So that is a very basic example of how curb roasting works. A question is, will evasion work if we run Rubius in memory? It depends a lot. There is a reason why I do not discuss a lot of EDR bypasses in the class. Usually, you would need targeted bypasses for an EDR. All right, the EDRs collect a lot of telemetries. They are not silver bullets, but pretty annoying, to be honest. Now, when you say that would the evasion work if we run Rubius in memory, I would say for what? Against the MDE, Microsoft's Defender for Endpoint, or against Carbon Black, or let's say the CrowdStrike, or what? All right, so the best way, to be honest, is if you want to bypass EDRs, heavily customize the tools that, if you are using open source tools, heavily customize them. If you frequently encounter EDRs in your penetration tests or red team operations, then modify available tools or write your own and do not upload them to VirusTotal. And if you are a consulting shop, try not to share them. I mean, that goes against the spirit of sharing, but that's unfortunately a truth. And that is why there has been recently a boom in commercially available open source security tools for offensive security. Right? Is there a way to find what encryption is set for Kerberos authentication? And should we always need to use most secure encryption to avoid detection? It always makes sense, especially before requesting the tickets, while requesting the tickets, it always makes sense to use RC4 offset codes so that you do not end up getting detected because of an encryption downgrade. And this is how you check it. All right. In our initial run, you get to know if RC4 is in use or it is AES. A very good question is, can Active Directory be hardened against using RC4 actions? I would say sort of. So why sort of? In my experience, see this magic. So here we turn on AES for service account. And here you would see this. If we run RC4 OPSEC, we won't get any tickets. But if I remove that, I would still get one for service account. What's that? What is this sorcery? Turns out, and once again, we have explicitly made sure that AES is supported here. All right. Then why? Why is it possible? So it turns out that it is the requester, the requesting client. Requesting client can forcefully downgrade. Requesting client controls that, okay, no, I need the service ticket in RC4. I don't know, I need it. Right. So it turns into a cranky kid that, okay, I would absolutely need it in RC4. Same goes for the protected users group. Even in case of protected users group, ideally, you should not be able to get a service ticket that is RC4 encrypted. But the client can dictate that. So the only way of hardening it is absolutely remove any type of NTLM auth or RC4 in your domain, which is not an easy task. However, you can generate signals as you would see here. I mean, make sure that all of your normal traffic uses AES, and then if someone forcefully downgrades, then it would stand out. Not only using tools like MDI, even that is visible in the logs. For the 4769 that is generated here, you can look at the E-type. In the log 4769, you would see an E-type. If that E-type is 0x17, that means a downgrade. So there is not always a need of using tools like MDI for that. Even your correlation in your scene can alert you on that encryption downgrade. Another privilege escalation or another variant of Kerberos-roasting is targeted Kerberos-roasting. So in case of targeted Kerberos-roasting, we can forcefully set SPNs. So the idea is pretty simple. If we have generic all or generic write permissions on a target user, you can forcefully set SPN on that user. The only requirement for that is, I'll come to that in a moment. So you can forcefully set the SPN and then Kerberos it. All right. For example, if we check what are the permissions, let's say that the student users group has on any user in the target domain, you would find out that there are so many support X users where the student users group has generic all permissions. Once we find out any such user, we can set an SPN for them that is unique for the forest, unique across the forest. So the first requirement is that the SPN must be unique across the forest, and the second requirement is it must be in the format or string / another string. That's it. You can use whatsoever you want, and if it is in the correct format and unique across the forest, the KDC will accept that. And once you set the SPN, then you can Kerberos the support one user. All right. So once you set the SPN, then we can request a service ticket and brute force it offline. That is what our hands-on 7 is, but I don't think there is any need to actually show that. It's pretty much the same as we did earlier. The only difference is this enumeration and setting up of the SPN. Once again, please keep in mind, any user that has non-null service principal name is a service account for the KDC, and any authenticated user can request a service ticket for that. Absolutely no special privilege is required. All right. Now, continuing our discussion on privilege escalation, let's talk about LAPS. LAPS, that stands for Local Administrator Password Solution, is a free of cost solution from Microsoft for solving a huge enterprise security problem. Even today in 2022, a lot of organizations use same or similar password for local administrator accounts on their Windows machines. That is obviously not good and can lead to catastrophic results. So what LAPS does, that is free if you have enterprise license. What LAPS does is it can periodically randomize the password of local administrator or any other local user that you specify, change that password and store that in the Active Directory database in clear text though, but stores that in the Active Directory database. Excuse me. So that would mean that even if you compromise a machine and get your hands onto the local administrator password of that machine, if LAPS is in use across your enterprise, all of the local administrators would have different passwords. And the management would not be nightmare, because your help desk or administrators can make a single query to Active Directory to get the password in clear text and use it. All right. If I quote Microsoft's documentation, it says it mitigates that is LAPS, mitigates the risk of lateral escalation that results when customers have the same administrative local account and password combination on many computers. Please note that the password is stored in clear text. However, the transmission is encrypted because Kerberos is used here. LAPS is configurable using GPO. And the property MS MCS ADM PWD on the computer account that stores the password that has access control using ACLs. By default, only domain admins, and if you add more users, only those users can read the passwords. So when you install LAPS, let's say at the domain level, all the computer accounts now have two additional attributes. Admin password that is stored in MS MCS ADM PWD, and another one for the frequency to change this. Now you can specify, let's say, that your support staff can read that, and then they can use that password to manage a machine. The managed machine has, by default at this location, has a DLL called admpwd.dll by default at this location. Please note that even the managed machine cannot read the password. That is, even if you have system privileges on that machine, you can change the LAPS password, but you can't read that. By default, only the domain admins and other users that you specify can read the passwords. However, this also means that you can enumerate if labs is in use on a machine or on an OU and who all can read the passwords. That is, if we keep looking at this diagram, you can enumerate an attacker can enumerate who this support staff is. And that provides them a nice attack path that, okay, I've got this user who can read the lab's password for this OU. Let me focus on this user. Let me see if there is a shortest path to this user in Bloodhound. Oh no, there is no one. So let me find out other ways. So that is something that can be done. And that is why we are looking at labs in privilege escalation. However, please keep in mind that this does not absolutely should discourage you from using labs. It is a lot better, even if you can enumerate that, it is a lot better to use labs than having the same administrator password on all of your machines. A question is, so if labs is used, the local administrator would have unique and randomized password? Yes, that is correct. Another question is, can I specify any domain user to be a local administrator on some machines by using labs instead of using the local built-in administrator? Now, that is something that labs could not do. That is something that labs is not capable of doing. Labs is only to randomize the password of your built-in local administrator or other local users, not any domain users. All right. Now, how do you find out that who can read the passwords in any OU? So we can use this power view command, or we can use get labs permissions that uses the AD module, or you can use the labs module. Using any of these, we can find out that what users for what user or group, that is a security principal, who can read the password. So what are we doing here? First, we list all the OUs. Then we list ACLs for all those organizational units. Now, for each of the A's that we get from here, we filter using where object. If the object A's type is MS MCS ADM PWD, that stores the password. If the A's type is MS MCS ADM PWD and the rights in that A's are read property, that is, we want all those ACEs where any user has the rights to read this property. And then for each one of that entries that are returned from here, we want to find out the identity name. All right. So let's run this using Power View. Let me start a new command prompt for that. So you can see that in the OU mail MGMT, the MS MCS ADM PWT object can be read by the student user scope. All right. Once again, in the mail MGMT OU, the MS MCS ADM PWD that stores the password in clear text for labs can be read by this group, your student users. We can, of course, enumerate that using AD module as well, using the get labs permissions script. I mean, that's simply something that wraps AD module commands. You see that on OU mail MGMT, student users has read rights and self has write rights. That is, a computer can modify the password but can't read it. Now, once we know it, how do we abuse it? I mean, it's open and shut now. We know that our current group has those permissions to read the password. We can simply go ahead and read this property. That's it. I mean, I've simplified it a bit for the lab, but once you know what principal can read the password, and if you compromise that principal, it is as simple as that. Recall that we have already enumerated that it is the US mail MGMT machine that is a member of the mail MGMT OU. So we can now simply go ahead and do this. We want to read from US mail MGMT this specific property, and then we would like to expand it. And this is the password for the local administrator user there. All right. That is how you can abuse labs. Once again, not absolutely discouraging it. In fact, as you would see, I recommend this as a defense mechanism later on. Just be careful who can read passwords. Sorry, who can read passwords in clear text for your local administrators. A question is labs considered a service? If yes, what does it run on? No, labs is not a service. Think of labs as a security control, not a service. If we have control over it, can we control the randomization frequency? Yes, you can. Check out the labs module. If you want to go into the details of implementation, yes, you can control the frequency. Right? Although recall the privileges that you would require to change the frequency. I think domain admins is required for that. You cannot have, so I like the way you're thinking. You cannot have perpetually same password. All right, that would be nice to have as an attacker, but I don't think that is possible. All right. Now, can I set a password as a DA? Yeah, exactly. I mean, by default, you can't, but that would not be required. And as real mom x82 mentioned, you can use it for persistence. Let's check out this blog post and this paper for that. And that was our hands-on aid. We required to identify OUs where labs in use and users or groups or principals who have permissions to read the passwords, and then abuse those permissions to get the clear text passwords. Question is, can we use labs for a root admin account? No, I didn't get that. Could you please clarify? Teapot? That is the domain? No, absolutely not. Not recommended. Not recommended. So it is recommended only to be used against the local administrator. You would not like your domain admin password to be something random. It is only for the local administrator and not for the local administrator on the DC as well. I mean, the DSRM administrator, not recommended even for that user. right? So now in this one, we compromised US mail MGMT by abusing lapse. How did we compromise that? Because we now have the password for the local administrator of US mail MGMT. That is why. Now let's start talking about lateral movement now. Once we have local administrator privileges on other machines, let's take a look at how we can execute lateral movement. What are the tools that we can use for that? First and foremost, Mimicards. So Mimicards is a very versatile tool that we can use to extract credentials, tickets, create tickets, forge golden tickets, and whatnot. Invoke, so we are going to use a bit of both Mimicards and invoke Mimicards as and when required. Invoke Mimicards is a partial port of Mimicards. It reflectively loads the Mimicards executable in the memory of partial process. All right, and you would need privileges on depending on what is the action that you would like to execute. So once you have administrator privileges on machines, the first thing that comes to your mind, although that should not be the first thing, touching LSS is something that you should not do as the very first thing. However, that is still a part of a SOP, standard of operating procedure for a lot of red teams and almost all of the penetration testers. How do you extract credentials from LSS? You can use secure LSA L keys using invoke Mimicards, or you can use safety cards that create some mini dump of the LSS process and then uses PE loader to run Mimicards. You can use that. It is a C# or .NET binary. You can use Sharpcats, that is C# port of some of the Mimicards functionality. You can use Dumpert from Outflank that uses direct system calls and API unhooking to avoid detection. So we are using a Microsoft signed binary to run Dumpert here in this case. You can use PyPyCats that has Mimicards functionality in Python. You can use Microsoft's own binaries like run DLL32 and COM-SVCSDLL for creating a memory dump of the LSS process, and then the credentials can be extracted offline using tools like Mimicards. You can also use tools like LSASI, NanoDump, and whatnot. I mean, extracting credentials from the LSS is the peak of the classic cat and mouse game. All right, you would have some technique or tool out every second month. That publicly available technique would work for, let's say, a few weeks. Then slowly, the detections would start, and then probably you have to heavily, or not heavily, you have to at least make some modifications to the tool, probably not the technique, but the tool, to still be able to touch LSS. All right. If your attacking machine is Linux, you can of course use Impacate or FizzMem to profit and so on. I mean, I can't keep this slide updated. There are so many tools that come in and go out when it comes to touching LSS, but you get the idea, right? If you have local admin privileges on a machine, and if you cannot find credentials anywhere else, like let's say in the LSS secrets or registry keys or in SAM Hive, then go ahead and extract credentials from LSS using any one of these. All right. The question is, can we run Mimicards remotely? I mean, you can. I've seen people running tools like even Mimicards over a SOX proxy. So that would help. That may help, not that would help, that may help in some avoiding some detections. Where can we find credentials other than LSS? In the SAM Hive that stores local users' credentials, LSS secrets that stores service account credentials, registry keys. All right. Your what's that? Your credential store that stores credentials for uh, saved RDP sessions and similar stuff, right? I mean, not only RDP sessions, but your credential vault that is encrypted using the DP API key. So all of that would not require interaction with LSS. The question is, when we bypass MZ and run Mimicards in memory to extract cred from LSS, how noisy it is. It is very noisy. See, there are two types of detections. One is the tool-based detection. That is, when you bypass MZ and run Mimicards, you avoided any signature-based detection. But then the API calls that Mimicards uses in the background, all of the EDRs, any respected EDR will absolutely detect it. Mimicards is the most heavily fingerprinted tool on planet Earth. All right. So, as I said earlier, if you want to use in a red team assessment, I know that red teams, even my team used to do that. I mean, does that. When I very actively, I still do red team assessments, but we now have separate roles, and I'm not the operator anymore. So operators in my team, they do maintain different versions of tools based on Mimicards or tools that would have minimal API calls to create a memory dump of the LSS process and then analyze that dump remotely, that is offline. Running Mimicards directly is very, very, very risky. And having said that, even if you use your custom tools, a lot of times, not for the custom tools, even if you are using modified tools, you need to keep in mind what is the target EDR that you are facing. All right. The proc dump is also very heavily fingerprinted. Unfortunately, I mean, because it is our current class is a public class, the tools that I've listed there, most of these are pretty heavily fingerprinted. And that is the reason why I avoid discussing EDR bypasses. You understand that now? Anything that I share with you on that would be detectable within a couple of weeks or something. So that is why I handhold you only a bit here. And then it is up to the EDR that we face, and there is a plenty of information on that. All right. So look up the EDR that you're facing. See how you can avoid that particular one. That is the way. I mean, there is no one size fits all bypass for EDRs. I mean, I don't wish that there was one, but as a red teamer, I would wish that. So that my operations could be a bit more successful. All right. Yes, we're coming to that. We'll come to that. Now, another technique, let's say once you have a set of credentials that you extracted using Mimicards or any of its variants, then how do you use them? There is pass the hash, where you pass the NTLM hash and access local resources, that is resources that support NTLM authentication. Then comes overpass the hash, where you can create tickets or tokens from NTLM hashes or RC4 hashes and AES keys. The below commands need elevation, high integrity process. That is, you need to run them as an administrator. So use this or this. The module is secure LSA PTS, the user whose credentials that you have. FQDN of the domain, AES key of the user, and the process that you would like to run. Please keep in mind that this process that starts here, as let's say this user administrator, has a logon type 9 that is similar to run as /net only. Now, in case of logon type 9, this identity is used only when you access a network resource. For example, let's say this starts a cmd.exe. If you run a whoami on that cmd.exe, it will still show you your current user. That is student user, something like that, whatever the current user is. But let's say you try to list directories because this is the domain administrator. Let's say you try to list $C on the DC. At that time, this credential will be used, and it will only be the network resource that would see this identity. And that's what logon type 9 is. I mean, it's not nothing, it has nothing to do with Mimicards or the lab. That is how logon type 9 works in Windows. All right. A question is, where can we find AES256 keys? When you run secure LSAE keys, that gives you both the NTLM hash and AES keys, usually both AES128 and AES256 keys. All right, so is overpass the hash clear? Please always keep in mind to use AES keys. Do not use RC4 or NTLM hash unless there is no other way. Why? Because this can be detected, use of RC4 can be detected by tools like MDI, Microsoft's Defender for Identity. Right. So does overpass the hash always need elevation? Not always. You can use Rubius and its PTT/PTT to overpass a secret without needing elevation. However, please keep in mind that this would almost certainly, it overwrites the session key for your current session. So that will break everything else on the machine. You need to log off and log on once. So this would work in some scenarios if you do not need elevation. However, if you need to start a new process, even with Rubius, you would need elevation, absolutely always. All right, so that is what overpass the hash is. Another technique that we are going to keep coming back to is DC sync. Now, DC sync makes use of the replication protocol. Recall the 4 basic components that we discussed initially. One of them was replication. So DC sync makes use or abuse of that replication functionality with enough permissions, by default domain admins, but with enough permissions. You can go to the DC and request information, including the credentials for an account. And if you have that minimal permission, the DC will oblige, the DC will comply and provide you the permission. For example, here we are running a DC sync attack against the KBTGT account itself. All right. Now we took a look at some of the .NET tools here, for example, Rubius, safety cards, etc. So let's take a look at offensive.NET for a bit. Now, currently, .NET lacks some of the security features that are implemented in PowerShell, that is system management automation. Now, because of these, .NET has found a newfound love, right? A lot of red teams and penetration testers used to have .NET tools prior to PowerShell. They continued to have those tools, and they made a comeback a couple of years back. And then there are many offensive .NET tools that can be used. We'll use the ones that fit our attack methodology. Please note that we can always use even more exotic languages like Boolang or Nim or Rust or Go. I mean, Go and Rust are not really exotic, but you get the point. You can always move to more and more exotic and not so popular languages to avoid heuristic or behavior-based detections. But that is not everyone's cup of tea. Not each red team has enough research time to write a tool bottom up in a new language. So we usually have to limit to modify existing tools, open source tools. We content with that. The question is, can you explain the replication feature again? So the DCs need to replicate information among each other, right? So let's say there are two DCs in a forest or a domain, let's say, DC1 and DC2. They need to continuously replicate information between each other. Now, DC sync makes abuse of that replication feature. If you have enough permissions, by default, domain admin. Otherwise, with limited permissions, we'll see later on that there is a simple set of limited permissions that allows us to request replication. Either ways, once you run this, you simply go to the DC and request a replication for information about this account, including the credentials, and the DC complies. That is what the DC sync attack is. That is the gist of the DC sync attack. Right? So coming back to .NET, offensive.NET, what are the tradecraft challenges when you talk about offensive.NET? So there are many challenges. Three major challenges are: one, of course, detection by countermeasures like AV or EDR, or delivery of the payload in memory. For example, in PowerShell, there are sweet download execute cradles. If you would like something similar in case of .NET as well. And then comes detection by logging, like process creation logging or sysmon or command line logging. So what we are going to try and address is the simple AV detection, only Windows Defender, for the reasons that I've already explained, shelf life. So we'll discuss bypassing only Windows Defender. And please note that if the binaries that we have shared, the precompiled binaries that we have shared, if they start getting detected, you are on your own, because we discuss the ways to create those binaries as well. All right. So let's first take a look at AV bypass, not EDR bypass. Please keep that in mind. So to bypass signature-based detections, we simply need to find out, and it is actually pretty simple, to be honest. We need to find out what is the signature that a particular tool has, or what is the signature that, let's say, Windows Defender has for a particular tool that we need to change. For that, we can use Defender check to identify code and strings from a binary that Windows Defender may flag. So we can use that to, because we're talking about open source tools, we can change that string or code in the source code of the tool and then build it again to bypass Defender. Then there is straight away battering ram obfuscation as well. You pick up a binary and simply obfuscate all of it. So let's take a look at shortcuts with Defender check. If you pass shortcuts to Defender check, it complains about, it doesn't tell you the exact string, but it is usually at the end of this block. Usually, not always. I mean, would be something from all of here. So by trial and error, we found out that it is the credentials string in shortcuts that Windows Defender doesn't like. So what do? We open the source code of shortcuts, replace credentials with credents, build the solution, and check again with defender check. As simple as that. We can do similar thing for safety cards. So the steps that we used are, we downloaded latest version of Mimicards and out-compressed DLL. Out-compressed DLL is a script that, as the name suggests, can be used to compress DLLs or executables as well. So we compressed the Mimicards binary, copied that value in safety cards, changed the byte size because of the version change, some byte size would change, rebuild it, and voila. For better safety cards, what better safety cards does is it tries to download the latest version of Mimicards from Benjamin's repository, from Mimicards repository. So what we did, we downloaded the latest release manually, converted it to a base 64 value, and commented out this part of the code in better safety cards that looked for a URL or a path. In place of that, we specified a zip stream there. And we provided the value of that base 64 encoded value here, that zip stream here. And that's it. That would bypass Defender. For Rubius, just to test stuff, we used the bettering RAM approach. We used Confuser X. Feel free to use your own packer or obfuscator, and simply obfuscated the whole binary. All right, and that is it. I mean, you can use these reference slides. That's how we obfuscated Rubius as well. Now, please keep in mind that this bypasses signature-based detection. Now, there are behavior-based detections as well. In fact, even for Windows Defender. For example, as you will see in a few minutes, there is a behavior-based detection when we are using loader.exe, even for Windows Defender, and we'll see how we can bypass it. Now, that was the AV bypass part. How do we solve the payload delivery? All right. The question is, do you have any details on setting up Visual Studio to make those changes? Unfortunately, I don't have. I mean, there was no need to have any special setup for that, but I don't have any details on that one. Right? Any specific modules? I don't recall. I mean, that's my Visual Studio that I have on a cloud VM, and I mean, absolutely. And unfortunately, I don't recall. I don't think any specific modules were required, but I can't say that with absolute surety. I mean, it's that what I've been using for a long time now, actually. So thanks. So we can use NetLoader from Flankvic to deliver our binary payloads. The idea is to load binary from a file path or a URL, meanwhile patching MZ and ETW. What is ETW? Event tracing for Windows. Think of this as debug log. Just as an example, think of this as not debug, trace logs for events that are happening. Very, very good option for telemetry. All right, and I don't think there is any EDR that is not using ETW right now. So that helps in bypassing a lot of ETW-based detections as well. So what we use a modified version, a simply modified version of NetLoader. We rename it as loader.exe. That answers your question, real mom. So we made very minor changes to NetLoader. We name it as loader.exe. And then you can actually run binaries in memory of loader.exe by downloading them from, let's say, a remote machine. We also wrote this POC tool. This is what we wrote for the class assembly load.exe. That can be used to load the netloader in memory, and then in turn, the netloader will run the binary in memory. So when you run assembly load first downloads and executes loader in memory, and then it is the loader.exe that runs this binary in memory. Although we are not using that a lot because downloading stuff from remote web servers is really not silent and results in behavior-based detection from Windows Defender. But still a nice POC tool just for the heck of it. Armed with all this knowledge, let's do the hands-on 9. Extract credentials of interactive logon sessions and service accounts from US Mail MGMT. What is a US Mail MGMT machine? The one whose local administrator password is managed using labs. All right. So what are we going to do? We are going to first copy over. First, we are going to we need to drop loader.exe on the disk of US Mail MGMT. Please keep that in mind. We are dropping loader.exe in the memory because we have customized it enough that Defender would not detect it. So let's use this command. We are mapping this directory on US Mail MGMT to X drive on our current machine, on our student machine. That is the username that we are going to use. This is the password. All right, and then we will copy over loader.exe. It is already there. Okay, that's fine. Let me overwrite it. Right, and let's remove the drive that we mapped. Now let's access US Mail MGMT as administrator and the password using the password that we extracted. Please keep in mind that when you are trying this, if this password doesn't work, you can that may be because of some special characters. So you can run the commands without the password. It will ask for the password, and then that problem will go away. All right. Now we would like to use loader.exe this way. All right. However, if I run it like this, Defender will have a problem with that. Let me show you that. I just hope I don't break stuff while showing that. So if I let me start a local web server, HFS, so that I can serve files. If I run something like this, you will see that we got a Mimikatz prompt and then it was gone. Why? Because Defender detected that and killed it. All right, so to avoid that behavior-based detection, we can simply do this. I mean, there are multiple ways of doing that. One of the ways is what Defender, by trial and error, by different attempts, in multiple attempts, you would get to know that what Defender is complaining about is that this tool is downloading an executable from a remote location, which makes sense, right? So what we can do is we can create a port forwarding. What does this port forwarding do? We are forwarding port 8080 on the local machine and forwarding it to port 80 of my student VM. Make sure that when you are trying this, you use your own student VM's IP address here. Once I do that, then you would see, okay, even the loader.exe is gone. Let me copy that again. And let's access. Oops. Access USMail MGMT. And now if I run loader.exe, note the URL now. Now we are downloading it from the local loopback IP, and the request would be forwarded to port 80 on my student VM. All right, let's clear the log here and let's run it. You see that we still serve it, and now it is not detected. And let's run secu LSA ekeys here, and we will get the credentials for, let's see. This is your USMail MGMT, so we would get credentials for at least one user called provisioning SVC. Note the session here, service from 0. What does this mean? This means that this account is used to run a service on that machine on USMail MGMT. All right. And that was our hands-on 9. All right. We were able to access USMail MGMT by abusing labs, and then we extracted credentials of provisioning SVC from there. And yes, we can take a break now for 10 minutes. Okay, welcome back. There is a question. Is there any difference between run as with parameters username and password and WinRS with parameters username and password? No, there is no such difference. I mean, I prefer using run as more because that would need me to start just one process that would run with the privileges of the users whose username and password I would provide. And then we can run all sort of commands from there. But when it comes to noise, both are absolutely the same. The question is, can I do a run as from my um, Windows VM, attacker Windows VM, and run OPS? Yes, you should be able to do that. Is there a way to get a TGT on Kali if you know the username and password? Well, I believe yes. I think using Impacket you can. I mean, I've tried that. I do not have uh, the commands in top of my head, but yes, you can use Impacket to do that, to do all sort of things. If you have the username and password, of course. Is PX exec a lot noisy in comparison to WinRM? Yes, yes, it is. It is very noisy. I mean, PS exec drops an executable on the disk, starts a service that uses that executable. So it clears all the checks for how noisy a tool could be for little movements. So yes, it is. It is very noisy. Right? Any other question? Okay, here's another one. In a real assessment, I was using run as command and got the command CMDS that user, but I could not execute any commands other than viewing their file system, but can't dump hashes even though that user was a part of domain admin's group. Okay. Any idea what would have prevented it? Probably things like credential guard, or the target machine was running LSS as a PPL, protected process light. In both the cases, the usual secure LSA key sort of commands will fail. So that could be the reason. I mean, domain admin, when it comes to a local machine context, domain admin is no bigger than a local administrator, right? So probably credential guard or PPL or both, or probably some application allow listening solution. And all of these would break your capability to extract hashes. Our question is, how do you test red team attacks with SIEM or with something else? Just curious, how can I test the attacks and see if they are being logged and detected? I mean, we had this setup even in the current lab. You would see Winlog beat agents on your VMs. So you can use the similar approach. I mean, we removed that feature from the lab because there was not much demand of it. But you can simply set up, let's say, a Helk instance or any ELK based or anything, run an agent, so create a small setup, a DC and your attacking machine, and let's say Helk or any SIEM, run an agent and try stuff out. All right. You can always configure sysmon and winlog beat. That would cover a lot of attacks. Or you can use something like the detection lab that you can deploy on any cloud instance and then try stuff out. But please keep in mind the costs when you run anything in the cloud. Thanks a lot, real mom. Now, continuing our discussion on privilege escalation, let's talk about GMSAs or group managed service accounts. Before I forgot about it, please keep in mind that there was a recent attack discussed on GMSAs, that is Golden GMSA. Let me find a link for that. I've not included that in the lab yet because it takes some time before we push anything into production, right? That is in courses. But you can, I think I have it saved somewhere right here. So you may like to read about the Golden GMSA attack as well. Not included in the course yet because it is rather new. I needed to confirm it in a few real world assessments, and then we would include that. So that is something that the attack that I shared on Discord, that is something that you can read about later on. Right now, let's understand what our GMSA is, or what our GMSA is. A group managed service account is something similar at the conceptual level to what LAPS does. It provides automatic password management, SPN management, and delegated administration for service accounts across multiple servers. So Microsoft realized that a lot of their users are running services, the Kerberos attack that we saw, that a lot of their users are running services using user accounts. So they came up with managed service accounts in 2008, Server 2008. In Server 2012, they came up with group managed service accounts, or GMSs. Now, GMSA is usually, I mean, you can use it with standalone or single server as well, but it supports to be used with a cluster of servers, that is multiple servers. And it will automatically change password for the service account, will do the SPN management, and can delegate administration as well. It is recommended to use GMSA to protect from Kerberos type of attacks. When GMSA is used, a blob with password information is stored in the attribute MSDS managed password of the GMSA, right? And only explicitly specified principals can read that password blob. Even the domain admins can't read it by default. All right. So a question is, so GMS is like LAPS, but also changes service account passwords. I mean, they both address similar problems. There is no need to compare them, but they both address the same problem, that is static passwords. So what GMSA does is, a lot of times you will find specific misconfigurations or problems with service accounts. People would keep passwords that are very similar. For example, January at 2022, and they keep changing it every month. Or they will write passwords in description field or something like that. So GMSA takes that load off the administrators. So it automatically changes the passwords, but for domain accounts, not for local accounts. All right. Now, how do you abuse GMSA? First, we need to find out. How can we find out? Any GMSA has an object class MSDS group managed service account that can be used to find the accounts. If you're using AD module, we can simply use get AD service account. For Power View, we can use the filter on this object class that we want to look at only this particular object class. That will show you if there are any GMSAs used in the target environment. Now, the MSDS group MSAM membership or group MSA membership, this lists the principals that can read the password block. So this attribute that is represented by principals allowed to retrieve manage password, you can query that particular property of a GMSA to find out who can read the passwords. So when we run the previous command, get AD service account filter, we will get AD service account, we will find out that there is a GMSA called jump1 in the target environment. And when we run this command, we will get to know what are the principals, who all are the principals who can read the password blob. Now, once we compromise a principal that can read that password blob, we can then go ahead and read this attribute that stores the password blob MSDS manage password. However, that blob is in binary form, so we cannot retrieve the clear text password. So what we are going to do, using AD module and the DS internals tool, which is an open source tool, a fantastic tool, we will read the password blob using the AD module, and then using the DS internals module, we will convert it into NTLM hash. I mean, there is an attribute here called the current password, but that contains a password in clear text, but it is in characters that we cannot type. So there is no use of doing that. We convert it to NT hash, and then we can overpass the hash to use the privileges of the GMSA. This would allow us to access services, machines, server farms, or anything that account has access to. All right. When I say principal, a security principal could be a user, a group, a machine account, anything that can be assigned a role. All right. That's what a principal is. Any questions? So let's take a look at that now. Our hands-on 10 asks us to enumerate GMSAs in the us.techcorp.local domain, enumerate the principals that can read passwords from any GMSAs, compromise one such principal and retrieve the password, find if that GMSA has high privileges on any other machine, and then extract credentials from that machine. Let's do it. So first we are going to import the AD module. Let me check if we have that already on any of our. Now we do have Power View here. Let me import the AD module here. Let's start Inquisition. Import the module, the AD module, and list the group managed service accounts. That's the object class, and that's the user, jump1. Now, by looking at the properties of this group managed service account, let's list principals allowed to retrieve management password. There is a user called provisioning SVC who can retrieve the password. We've already compromised provisioning SVC. Where? Does anyone remember? We compromised the credential, the AES keys for this user from US Mail MGMT, just in the previous hands-on. So now we can use overpass the hash to start a process with the privileges of our provisioning SVC. So we start an elevated shell, a high integrity process, and here we can use safety cards and overpass the hash. Secure LSA PTH, we are using provisioning SVC here. That's the FQDN of the domain. This is the AES key that we copied from US Mail MGMT. And we want to start cmd.exe as provisioning SVC. This is running as provisioning SVC. But as we discussed, this is logon type 9. If you run who am I here, you will still see student user X. So how do we, when are the provisioning SVC credentials used? When you access or remote resource or network resource. So let's first start InvisiShell here and retrieve the password blob. All right. So what are we doing here? From the jump1 GMSA, we are listing the property MSDS managed password, and we want its value to be stored in the $password blob variable here. Let's check if this is successful if we run it from with the student user privileges. You see that? No output here. Whereas in this case, we do get an output. All right. So that means that, of course, we now have provisioned SVC privileges here. Now the password binary of the password blob is stored in this variable. Let's import DS internals now. And decode, convert it this command is from the DS internals module. And finally, we can convert that decoded password to NTLM hash. If you look at the decoded PWD, it has a current password that cannot be typed actually, that contains the password in clear text. And then we have the secure current password. That is this. So we are converting that to an NTLM hash. Let's copy that. And now we can use overpass the hash once again to start our process as jump1, the GMSA. Once again, using safety cards, let's run this. All right. That's the NTLM hash that we could use here. And now from here, we can check. So what our tasks were? Our tasks were to enumerate GMSAs that we have done, enumerate the principals that can read passwords from GMSA. We have done that as well. Compromise one such principal and retrieve the password for a GMSA. We have done that as well. Finally, find if the GMSA has high privileges on any machine and extract credentials from that machine. So let's load InvisiShell from here and load find PS remoting local admin access and run it. Turns out that the jump1 GMSA has admin access on US jump. All right. Please note that any such tool that hunts for local admin privileges may take some time to complete. For example, right now, find PS remoting local admin access must have found a machine that is turned off, so it took some time. All right. Now, this process is running as jump1, right? So let's start using that now to copy loader.exe on US jump. Yes, overwrite. Copy over loader.exe to the C users public directory of US jump. And remove the mapping. Finally, access US jump as jump1. Right. We will add our port forwarding to bypass Defender's behavior-based detection. And finally, we will use loader.exe to download and run safety cards in memory. All right. However, we were not expecting this. Why? Let's check if the program is still there. You would see that our loader.exe is still there. And why could we not execute it? The reason for that is, if we run PowerShell here, I mean, just for 1 second to run a single command. Let's check if an allow listing solution like device guard is in use. And it will turn out that yes, that's the reason. US jump has device guard configured on it. Device guard, or that is now known as Windows Defender Application Control, WDAC, that is configured on the machine, which is not a good news for any attacker. So what can we do now? Whenever we face an allow listing solution, any allow listing solution, what is an allow listing, or what was previously known as a whitelisting solution, is there are two ways where you can block malware on a machine. The classic way that the AVs, the antiviruses and EDRs use is block known bad. That is, they would have hashes of millions of malwares. Whenever a new process or an executable or a dealer or anything like that starts on a machine, a hash of it is compared with a list of, well, a database of known bad hashes or known bad malware or known malware. Now, allow listing works on absolutely the other side. That is, in place of blocking known bad, allow listing, at least theoretically, allow listing means that you allow only known good to execute on the machine. All right. Are you with me? Allow listing means that only known good code can run. Now, please answer this on Discord. What do you think is known good code? What can be classified as known good code? Signed by Microsoft, for example. What else? Sys internal tools, CERT, built-in tools, anything else? I mean, please keep them coming so that I can tell you how wrong you are. Run DLL32. Okay. Anything else you think that can be classified as known good code? Known hash to good company in a specific location. All right. So, I mean, as you could see, that that is the Achilles heel when it comes to any allow listing solution. Right? Of course, look at the LOLBAS project that I shared earlier. That literally means living off the land binaries and securities. That project documents Microsoft signed code, binaries and scripts that can run untrusted code. So to be honest, there is absolutely no definition of what known good code is. If you think that code signed by Microsoft is known good, no, absolutely not. We have been abusing Microsoft signed binary PowerShell.exe for some time sometime now in this course. And then there are run DLL32, MS build, and whatnot. I mean, loads of them. All right. And please keep this in mind. Device guard is a lot more advanced than app locker. I mean, app locker cannot absolutely protect you from an administrator. If you have administrative access on a machine, app locker is dead right there. But that is not the case with device guard. Now, whenever you hit something like device guard in an assessment, be absolutely very afraid of it. It is a very potent security control. Take it seriously. Even if it is, if you see that it is not in the enforcement mode, if it is in the audit mode, in that case, you would leave a lot of logs on that machine. Sorry, excuse me. So what is the way? What is the way out? Okay, a question is, can you say again briefly why device guard is superior control? It is, I mean, it is by design. If you compare it with, let's say, app locker absolutely does not protect you from administrators. If you have administrative access on a machine, you can incapacitate app locker just like that. But that's not the case with device guard. Device guard is very potent. I mean, if not configured properly, you can also incapacitate device guard as well. All right, how? You can go to this directory. Now, this code integrity, the directory actually contains the policy that is in use. If this policy is not pushed using group policy, if this policy is not implemented using group policy, if you have administrative access, you can simply remove it and restart the target machine, and your device guard would be gone. But if it is done using group policy, as it is the case in the lab, then it would be harder, because if you remove it and restart the machine, group policy will once again push it, and that would not be a bypass. So what is the way now? Look at, I mean, go ahead, although that is very noisy, go ahead and try the lolbas and see if there is a binary from Microsoft that is still allowed, and if you can do anything using that. Fortunately for attackers, unfortunately for defenders, I have never ever seen device guard in block mode in a production environment. Absolutely never. I mean, not on device guard, any allow listing solution. The administrative IT administrative overhead that you get if you use any allow listing solution in block mode is something that scares organizations away from. You would have angry users at your desk right away. I mean, ideally, you can, let's say, run device guard in audit mode for a quarter or something, and then you would be able to find out, okay, these are the executables that are required, let's say, for our finance guys. These are the DLLs that they need. Let's allow only them and block everything else. Unfortunately, the administrative overhead is going to be very high. Having said that, we have used this in the block mode here in the lab. So how do we now bypass it? Once again, try different lolbas. Now, one binary that stands out, although there could be a lot of detections around it as well, is run DLL32. Why? Because that has a major role in the user's experience on the VM. For example, try blocking run DLL32 on a Windows VM, and you would find out stuff like start menus will stop working. Or your overall GUI of experience will reduce a lot. And if you're using a virtual machine and it has secure boot turned on and run DLL32 is blocked, your VM will simply refuse to boot. All right, so that is why we can give it a shot. Now recall that we saw a way to extract credentials from LSS by using run DLL32 and com/ccs.dll. So let's use that. So we would first need the process ID for lss.exe that we can get using task list. So 716 is the process ID. Let me copy that. And then we can use that with, let me delete the existing LSS dump. I believe there is one on this machine. All right, now we can use run DLL32 with com/svcs.dll, which is also a Microsoft signed binary, and create a mini dump of 716, that is the LSS process, and save it here. Oops. All right, let's see if the dump is created. Yes, it is. And now we can go ahead and copy over this from the US jump machine. Okay, there is once again already one here. Let me delete that. All right. Now, please keep this in mind that this commands like this is what separates a lab environment and a real world assessment. You may not always have the access to using SMB, even in an internal environment. And that is what eats up time in a real assessment. Now you have to find innovative ways or some way to get this file that is not a small file, to get this file from that machine. And please note that because this is a single, a lab environment, that is why the LSS, the dump is so small. Otherwise, that would always be in at least in few MBs, not in KBs. It's a tiny dump. All right, how do you exfiltrate file if you do not have SMB? There are many ways. You can create or share on your machine if it is an internal environment. You can upload it to an HTTP server that you control or something similar. All right. Okay, there's a question. Other than SMB and RDP copy paste, what other ways are there? Convert it into a TXT and you can exfiltrate it over DNS. You can upload it to, let's say, GitHub or on a web server that you control. So those are the ways. You can literally commit it on a repository that you control. All right, so anything that allows you outbound access, be it the ICMP protocol or DNS or HTTP or whatsoever, you convert that to a text file or a base64, anything like that, and exfiltrate that. But that needs time and patience that we lack during the class, of course. Not during our assessments here. That is something that we are not interested in right now. Now, once we have the dump on our offline, on our attacking machine, then we can simply go ahead and analyze it using Mimicards. Please note that our student VM serves two purposes here, dual purpose here. It is also our foothold machine, and we are also considering it a part of the attacker's infrastructure. In a real assessment, you're of course not going to analyze that dump file right there on your foothold. You will copy it over to your host machine or whatever it is, and there you will analyze it. So we want to analyze this mini dump. Which mini dump? C80tools lss.dmp. We still need debug privileges just for the heck of it, and then we can run command. Let's run secure LSA keys. Okay. Did I run it as administrator? Let me try it again. I think I did. Let's try it again. So we want to analyze the mini dump of lss.dmp. Privilege debug. I don't think I ran it as administrator. And now let's run secure LSA keys. Let's get the dump once again. Then sorry. Let's remove this one. This is rather small, to be honest. I believe was it that I did not let it complete? Let's see. So let's run it. It is still the same size though. Let's try it again. Okay. So let's try it again. If it still doesn't work, I believe I need to give it a pass. One last attempt. Because I share this with some of you, there could be a reason that the file is locked by someone else. So let me create it lss1.dmp. And yep, I believe that was the reason. It was locked. And now if I copy that, yep, that was locked. lss.dump was DMP was blocked. That was the reason. So here, what do we get now? We get the credentials for we should get for webmaster, and I believe for AppSVC as well. Webmaster is also service from 0, and AppSVC is also service from 0. Please always keep this in mind. If you find this out, then you can absolutely always extract credentials in clear text. Not from a dump, but using LSA dump :secrets. Not in this case because we are running on a mini dump. But if you are on a system, this extracts credentials from the LSA secrets, and this is for service accounts, and absolutely always you will find credentials in clear text. Not in this case though, because here we are operating on a mini dump, not on a live machine. All right. So that was our hands-on 10. All right, we discussed a lot of interesting concepts here. Group managed service accounts, how we can abuse them, how we can extract credentials. We also saw how we can detect if an application allow listing like device card is in use, and are there any ways to bypass it? I mean, I say bypass here with air quotes. It's not a bypass if you find it using a trial and error and the binary was not blocked. So, I mean, it is fine though. If you can find a way to get your job done, that's great. So here we are right now. We accessed US jump and extract credentials from there for a couple of accounts. Now we can start talking about domain privilege escalation. We have discussed enough movement and privilege escalation to other machines in the network, in the domain. Now we can start looking for administrative access to the domain controller, that is domain admin privileges now. So a question is, how can then device guard be bypassed? Yes, that is most of the times that we will do, unless you spend your best years studying device guard. That is the way. That is, you find out if a well-known binary or script that allows you to run untrusted code, is that blocked or not? Now, what we are going to discuss now is of a very interesting topic, delegation. All right, so please note that there is a lot of text on these slides. So you can always ignore the text. Focus on what I am saying. So what delegation allows you to is to use or reuse the end user credentials. So if I quote from Microsoft, it allows you to reuse the end user credentials to access resources hosted on a different server. So what are delegation issues? We call this we have access to US MGMT. But even if you try to use this, we get an access denial. What is this? This is the Kerberos double hop problem. Thanks to delegation issues. Let's say there are 3 servers. A, B, and C. In this case, in our current case, it is the US MGMT machine. We PS remote to this machine. This is now the first hop. We hopped from A to B. Now, when you try this net user DOM, there is an authentication. There is not an authentication. Yes, your credentials from B to C must be forwarded. C is here USDC. However, as a security measure, by default, other than the domain controllers, no Windows machine is allowed to delegate your credentials to a second machine. So B, that is USMGMT, will not delegate your credentials to USDC, And therefore, you get an access denied when you try to use this. This is the second hop, and this is the Kerberos double hop problem. First hop you accessed using your credentials, but first hop will not delegate credentials to second hop, Kerberos double hop. How do you address this problem? Using delegation or using explicit credentials. That is, you specify clear text credentials with the request, or you can use CRED SSP. CRED SSP caches credentials in clear text, so you can use that, or delegation. Now, this is what we're going to talk about, delegation. So this is something that I used so that you can connect with it, the Kerberos double hop problem. But more than this, the problem that forced Microsoft's hand to introduce delegation in Server 2003 was this. Let's say there is a user, do not look at the rest of the arrows right now. Let's say there is a user who authenticates to the DC. Step 1, 2, 3 are the same ones. You know, the user's timestamp is encrypted using their hash of their password sent to the DC. The DC provides TGT. Step 3, the user's machine presents the TGT back, requests a TGS. And then the user presents the TGS to the web server that they authenticate to. Now, of course, the why delegation is used to access resources hosted on a different server. Now, let's say this web server wants to access some information or the data hosted on this database server. And what it has is only a service ticket or a TGS. How will the web server request data from the database server as this user? Why as this user is required? There is why user impersonation is required. The need to know basis. There might be some other user who would have some different type of access here. There may be an admin. Let me create a hello over the admin. Then admin may have access to a lot more information. So to be able to request proper data from the database server, the web server must have a way, must find a way to send this request to the database server as this user. That is, at the end, user impersonation must take place. That's the basis of all types of delegations. User impersonation must take place. The first hop, which is web server, must have the capability to connect to the second hop, that is the database server, as the user that came in here. All right, that was the problem. This was the double hop problem in that not only the administrators faced. This is the problem that only the administrators faced. This is the problem that end users faced. So what Microsoft came up with in Server 2003 was unconstrained delegation. So the idea is something like this. The user or the user's machine on behalf of the user completes the authentication with the DC step 1, 2, 3. Step 3 is where the user presents the TGT and requests a TGS. Now, when at the end of step 3, the user requests a TGS or a service ticket for the web service, the DC checks that, okay, that web server has unconstrained delegation enabled. That is, it would need to impersonate this user. So in step 4, when the DC returns the TGS, and this is a representative diagram that I'm going to create, that's not factually correct. What the DC does in step 4, it sort of encapsulates user's TGT inside the TGS. So in step 5, this is what the user presents to the web server. Can the user decrypt the TGS? No. Can the web server decrypt the TGS? Yes. Because The TGS is encrypted using the web server service account. So it removes the TGS or decrypts the TGS, and now the web server has access to the user's TGT. What does the web server do with that TGT? It presents the user's TGT to the DC, requests a TGS for the database server, thereby completing the impersonation. And in step 7, it presents the TGS to the database server and gets access. Please note that in Kerberos world, if you have a user's TGT, you have that user's credentials. You can, and a TGT and a TGS are portable. You can extract the TGT from a machine and can use it from some other machine. All right. Is this clear? Now, there are obvious problems with this. This means that if your web server is compromised, you can access, there is no restriction, right? So you can access not only the database server, but any other machine, including the DC as the incoming user. And if this guy was a domain admin, then that means that if your web server is compromised, your entire domain and forest is at risk of compromise. All right. How do we abuse unconstrained delegation? This is how you set it up, unconstrained delegation. What does it look like? How do you enumerate? Using Power View, you can use this command. Using AD module, you can use these commands. I mean, usually there is no need to enumerate users, but if you want, you can. Once you have found out a machine in our lab environment, it is, I believe, let me run that. It is the US web machine, I believe, that has unconstrained delegation enabled. Let's check that. If I run this, please note that domain controllers will always show up, so you can ignore that. US web is the machine that has unconstrained delegation enabled in our lab environment or in our target environment. Now, once we have compromised the machine with unconstrained delegation enabled, there are a couple of ways how you can abuse that. You may need to trick a domain admin or any other high privilege account to connect to a service on US web. Once the account is connected, we can export TGTs using this mimicards command, and then we can reuse the ticket for that high privilege user. All right. How? For example, this is something that I used years ago, but still holds true. You can, for example, try social engineering or whatsoever, or you can simply wait out that if a high privilege user connects to the machine. However, all of this changed with the printer bug. That is, in place of waiting or tricking a user, how do you force a high privilege user to connect to a machine with unconstrained delegation? We can use a feature of MS-RPRN, that is the protocol used by the print spooler service, where if any domain user, that is any authenticated user, and in such a case, any domain user can connect to a machine and tell it to notify the user on another machine. So the user will say, please notify me on server 1, and server 2 will connect to server 1 using their machine account. And now the user wears a balaclava, so it becomes an attacker. That is what we are going to do. Using MS-RPRN, if you have compromised US web that has unconstrained delegation enabled, we will tell the DC that please notify me on US web. We are forcing the DC. The DC cannot say no to it. USDC dollar authenticates to US web or sends the ticket to US web. We extract the TGT of USDC dollar. USDC dollar is the domain controller account. Please note that the domain controller account, a machine account, cannot log on interactively. But what a domain controller can do is to run the DC sync attack. And that is what we are going to do now. All right. So let's do this. And once we have the TGT, let's say, then we can use it to run the DC sync attack. How do we run MSRPRN? We can use this or spool sampler to force the authentication, and then using Rubius, we can capture the TGT. Now, because the printer bug has been around for a few years now, many organizations have started disabling the print spooler service on their DCs. So you can use petit potam. What petit potam uses or abuses is a function EFS RPC open file raw of the MS EFS RPC, encrypting file system remote protocol. So you can also use that command petit potam to trigger a force authentication. Please note that for the DC, you don't even need credentials to trigger it. Is SPN hijacking? Are you talking about that, Carlos? So question is, isn't it possible to get an interactive shell using a machine account by abusing S4U and modify the SPN attribute of the ticket, because that property isn't encrypted? SPN hijacking, is that the attack you're referring to, Carlos? I believe that is what the attack is. So yes, that if that is even that is possible. But I would say that executing that against the domain controller account, that I would say is not very smart, to be honest. All right. So in using either petit potam or MSRPRN, we can trigger a force authentication that would lead us to capture the ticket. And once we have the ticket, we can pass it using Rubius or Mimickers, and then we can run the DC sync attack. Right. So let's take a look at it. So we need to find a server in the target domain where unconstrained delegation is enabled, compromise that server, and get domain admin privileges. Let's do it. So we've already seen that. It is the US web server that has unconstrained delegation enabled. Now remember that we have compromised a couple of users from US jump, credentials for a couple of users, webmaster and AppSPC. Let's start a process as webmaster and check if that user has admin privileges anywhere. I mean, it would have. Please always keep that in mind. Whenever we compromise a user and we are stuck, we can always check if that user has local admin privileges on any other machine. So we'll start a new session, a new process as webmaster using overpass the hash attack. And let's see if this user has administrator privileges on any other machine in the domain using find PS remoting local admin access. So we got it on US web. We can directly specify computer name here as well. For example, if we were interested only in US web here, we can tell that, check that right away. All right. So now we will copy over Rubius to US web. Let's access it and run Rubius in monitor mode, but only for one account, USDC dollar. We are right now interested only in tickets of USDC dollars. So let's leave it running in the monitor mode. Here on the student VM, let's trigger the force authentication using RPRN, MS RPRN. All right. And you've got the TGT here. So let's copy this. Please note that this ticket can be used with Ruby SPTT without elevation. However, the tool that we are going to use after that for DCSync needs elevated privileges, shortcuts. So we will start a command with elevated privileges. We'll use pass the ticket, rubies.exe ptt/ticket. What's the ticket? This is the ticket. Ticket imported successfully. If we run klist, you'll see that we have a TGT for the USDC dollar. And now we can simply run DCSync against the DC, against the for the Kirby TGT account. So we've got the hash, NTLM hash, and AES keys of the Kirby TGT account that would allow us to create a golden ticket. What is a golden ticket? That is something that we'll discuss in the next session. All right. Not only Kirby TGT, I mean, if that looks not interesting right now, you can, for example, go for the default domain administrator as well. All right. That's the hash of the default domain administrator. You can use that with overpass the hash to access any resource in the target environment. All right. Any questions? So now we have extracted the USDC dollar ticket from USFAB. All right. Now this was obviously bad. So what Microsoft introduced was constraint delegation. So in case of unconstrained delegation, if the first hop is compromised, you can access any resource in the entire domain as the incoming user, or in fact, as the domain controller, or that results in domain admin. In case of constraint delegation, first hop can access only specified services on specified computers. That is, a limited set of service principal names are accessible to the first hop. Once again, even in this case, user impersonation must take place. What we are going to look at is constraint delegation with protocol transition. Okay, we just have 5 minutes left. I thought we have 35 minutes left. I actually wanted to cover constraint delegation today as well. Okay, we're not going to rush through it. Just give me a second. Let me check how much ground I need to cover in the next session. We are almost on the track though. I just wanted to cover hands-on 12 today, in addition to 11. Okay. Okay. No, we can actually end the session right here. Uh, what we saw was up to unconstrained delegation and hands-on 11. We have a total of 27 hands-on, and I believe we would be able to cover up to 18 or 19 or probably 20 in third session. Please note that some of the hands-on are pretty straightforward. For example, 2 of them would be using or abusing unconstrained delegation to compromise a trusting forest and to compromise our current forest. So we should be pretty fine covering those quickly. All right, so any questions on whatever we have discussed up to now or anything from the course? No questions? Okay, so then we completed up to hands-on 11, and I will see you in the next session. Please note that, please come prepared with this. I don't think we have to extend the time, but in the next session, because the sessions are recorded, if I feel that we have not covered enough in the next session, I have to extend the time a bit. All right, not a bit. I mean, I will cover it. If I have to extend it by, let's say, 30 minutes, I will. Because the sessions are recorded, I hope that is fine. I don't think it would be required, but if required, I will do that. All right, I hope that is fine. If it is not fine, just let me know. All right, and please feel free to ask questions, break the lab, try the stuff out, and let us know if you break anything. I'm not going to hunt you down and murder you, even if I want to. If you break the lab, just let us know and we'll fix that. What is the week's objective in the lab today? So, you need to complete up to hands-on 11. And when it comes to the flags, let me quickly check that for you. It would be up to flag 21. So this would be hands-on 11 and flag 21. All right, will we abuse Exchange servers in the course? There used to be one actually, but Microsoft simply abandoned Exchange servers when that proxy shell abuse came out. And I see that they have no interest in maintaining on-prem Exchange servers anymore. I mean, even the advisories sounded like that. So I still have the ACLs of Exchange setup in the lab, but we have turned off the Exchange server. I mean, there are organizations, a lot of them, who still use Exchange on-prem. But a lot of my students ask me that, okay, this is something that is not worth including in the course anymore as Microsoft has abandoned it. And that's true. So I removed that. All right. Are there any other questions? Okay, so because there are no more questions, I'll see you in during the next session and on the screen. Bye-bye.